Welcome to part 2 of the dynamic blend modeling tutorial. This is how your curves should be looking, and you should have a feeling of G3 at both ends of the curve with a nice curvature and the peak more or less in the middle of the curve. And here, because the angles are different, we have a shallower look. And always use a construction plane to planarize your curves to, because Alias works a lot better at building patches if you have planar surfaces wherever possible. Now it's a question of projecting a curve around here for the footprint of the blend, and also in F6 projecting a curve which will give us the trim edge for our blend, or the curve on surface for our blend. This is my next step. I stress that this is the way I do it. It's not necessarily the way that other modelers do it. I do it like this and it works. Take a degree 5 curve and shape it to meet actually the end of this curve here. So, and you see that it kind of passes through the end of that curve. In fact, we can adjust it just a little bit maybe. Let's try to do. And then put a comb on it, and the most important thing is that it's not no inflections here. It wants to be fairly straightish along here, and then have a nice curvature up there. We're not going to deal with the whole shape of this cos in one projection. We're going to use 2 projections to do it. So this is our first projection. So having done that, you can project that onto this large C-pillar primary surface. The next stage is to put a degree 5 curve around here. I've got degree 5 single span. You might need to put in an extra 2 or 3 spans into your curve, and then shape this curve so that it comes here to the y equals 0, that you have curvature at that point to the other side of the model, and then down here it must pass through the NCV on that curve there. And then when you've done that, obviously you have to bear in mind here this must run down the shoulder and be parallel to the side glass. So that's very important. You must set that up. You do that by attaching another curve here, shaping it to be sympathetic to the side glass, and then aligning this curve to that one. When you've done all that, you can project it. I've put the deck here templated in on the screen just to show you how this curve is sympathetic to the line of the deck primary surface. And when you've done all that, you can project it down onto this shoulder surface. The curve I projected onto this C-pillar primary surface in F6 came along here. So this is the curve here, and it came along here. So that would have given me a patch this shape, but I know from experience that that's not going to build a good CV structure for this very let's say a stressed patch. And in fact these 3 patches are very difficult to control. These 2 are very easy, because here you're going round a curve. So what I've done actually is I've put a degree 5 curve, aligned it to that curve on surface there, and then just brought it up here. But I haven't just done that, I've also made sure that it's going to be curvature continuous in this direction. This is the comb and the curve and the comb in F7, and you have to be very careful that you have curvature to the y equals 0 here, and then in F5 nice smooth curvature and curvature to the center in this view as well. With that curve established, we know that we can build a surface from the end patch when we've got it to create our deck from. That's the deck secondary surface of So we don't want this piece of curve on surface here, so we can detach it at that point there and do that very accurately, and then delete it, and then reproject this curve, or project this curve here. So you have the initial curve on surface there, you've detached it there, you've aligned a degree 5 curve to here, which you've direct modeled at the end, and then you've run a curve from there to y equals 0. You've found curvature here, you've shaped this curve in both views, and now you are ready to project this curve onto the C-pillar, and that gives you the, if you like, the trim edge that you need to build these patches. Now I want to show you a method that I use to ascertain where this blend is going to be located, or in other words the footprint of the blend. It's an alternative method, but I use it quite a lot, and it's used by a lot of top modelers that I've watched working over the years. Just put a curve where you imagine that the blend might want to end, and another curve where you imagine that the blend might want to start, and put them roughly at the angle you think the blend is going to be at, more or less, and then project those two curves, and then just project these two curves, this one onto the shoulder and this one onto the C-pillar. Now just put a freeform blend spanning those two curves on surface with curvature, and it's a good idea to turn on your CV HUD so you can see what's going on. Okay, we're going to go into F5. Now we can use the move CV tool to manipulate the curves. So I'm going to turn off the locators, we don't need those, and we know that this curve is going to need a bit of curvature in it. So we shape that to an imaginary curve, and also we know that this one here is going to have some curvature in it. So let's adjust that. I'm looking at the CV structure and making sure that there's no kind of kinks or glitches. You see, we've got a nice beautifully arced CV hulls there, which is what we want. We can look at it in F6, and we can move this by picking the curve. We can move it in or out. This is the wonderful thing about Alias, is that the direct history is extremely powerful, and that gives us some idea of what we're in for. We can put the zebra stripes on, and we can start to assess the flow of the highlights that we're going to get. So as I move, the master curve, we can see there. So I'm going to put it back here, but when you're building a concept model, it's a very useful way to lay out your model in the early stages. And if you're working with a designer, you can get him or her over and you can say, this is what it would look like if I had it here, so on and so forth. Okay. Also, you can pick the curve, center its pivot, and then rotate the curve like so, to experiment with the shape of this footprint, the curve on surface that you're going to build here. And why are we doing all this? Well, we're doing it to get the best highlights that we can. If I, for example, just pick that surface, put some stripes on it, you can see that it's flat there. See, it's quite nice here, but it's flat there. So now I'm going to pick the curve again and pick rotate again, and I'm going to rotate that and watch this highlight. Yeah. Okay. Now let's pick move, and we'll move that in, and you see how the highlight changes. So we move it out too far, and we're going to have a flat section there, which is going to be a bad highlight. So we might want to compromise on the position I had there, and then we can move the whole thing like this and like that. And if we go into F8, it becomes more meaningful then. So we're assessing how our highlights might look with the patch in various positions. So you do that there, and you work out the line that you want here, and we can do the same here. That's about it. That's about what we're going to get with the lines that we've decided on, and it's going to look like that. But the main thing, the thing I'm interested in, is that the CV hull is beautiful. The CV hull hasn't collapsed, it hasn't dipped, and it hasn't caused much of a lip here, which is something that happens a lot on C-pillars. And if you get a lip there, then you can't build the transition surface and then ultimately the deck surface. So that's a very, very good way of planning out your transitionary surfaces. You can use it anywhere on the car, not just on the C-pillar. And I want to finish off by turning off the locators and hiding the model, and then now it makes a lot more sense, doesn't it? Look at that beautiful flow down the C-pillar or continuation of the cant rail into the shoulder surface. Beautiful, beautiful. You know, I've often worked like this with the designer sitting next to me or watching me over my shoulder and saying, move it in a bit, move it out a bit, but I think that's really wonderful. So this is our patch here, and here there it is flowing down there into the deck. Now this, I suppose, is the acid test. What all this careful painstaking work has been leading up to is this array of CVs, and you'll see that we have a smooth CV hull, could be improved further. We know we have a low CV there, which means that there'll be a CV in this patch which needs adjusting to raise that CV, but basically speaking, it's not a bad array of CVs, and this is what you're aiming at in Alias. The patch that we were setting up here at the beginning of the video, I've actually moved it further that way there, and this was our original curve, and curves are always a starting point for me. When you're doing high quality work, you can't expect your original curve to serve you right the way through to the Class A surface. You use the curve as your starting point, and then you start to manipulate your surfaces. In this case, easy to do because we have a free CV row there because it's a degree 6 surface, and we can you know, change the depth and the peak, if you like, of this blend by raising and lowering that with CV transform NUV. So there we are. That's a look at our CV hull, and the way that you'll be judged when you enter the world of automotive is by the neatness at which you can model and the speed at which you can model, and certainly everybody that comes into contact with you, including your modeling manager, will be looking at the quality of your CVs, because they tell a lot about you as a person, how tenacious you are, you know, how dedicated you are to your work. Let's take a quick look at the model with the zebra stripes on, and the whole point really of this C-pillar that my students are modeling at the moment is to get this beautiful G3 curvature continuity here. You can see it there, and you can see it around there. And then finally, to close the tutorial, I'm using the ISO shader here and dynamically assessing the model. You can see that I'm looking here at the G3 continuity, and I'm looking also for defects. And if I'm going to be honest, I can point out here that there's something to investigate there, perhaps a bit of a flat spot in the model, but generally speaking I'm very happy with those surfaces. These lines here, the visual curves, tell you an awful lot about what your surfaces are doing. Here it's all looking very jolly. It's just this area here that, as I say, that needs further work. Okay, let's just finish off with that. It's a perspective view, gives you better shading. I've been Graham Bullock, CEO of learningalias.co.uk. Thank you very much for taking the time to watch my video. I hope you found that interesting and useful. Thank you. Bye.